about empirical molecular formulas? You should be writing this down. Not talking. I love you so much. Okay, so I think we had talked about last week the formula for glucose. So what this means is if I were to draw out the molecule glucose, you in the picture, do you remember what glucose kind of looks like? A little ring with stuff hanging off the edges of it. Do you remember that from biology? No. Maybe? Well, if you don't remember what glucose looks like, maybe I can show you in a minute. But it's got 6 carbons and 12 hydrogens and 6 oxygens. So that is what the molecule has in it. That's the actual shape. So anyway, if I ask you to write the subscripts, so I mean these things, if I told you to rewrite this formula and do the lowest ratio you could on the subscripts, could you do that for me? Could you reduce them down? So go ahead and do that on your own silently. Just to make my point, I'm going to look up a picture of glucose for you. So if you look at this picture right here on the left-hand side, that is what a molecule of glucose looks like. And if you count up all the atoms, like so if I count up the carbons, I'll see 1, 2, 3, 4, 5, 6. And then if I count up the hydrogens, I'll get 12. And if I count up the oxygens, I'll get 6. So that is the molecular formula. So what I mean by that is this is actually telling me how many atoms of each are in the molecule. So I didn't want you to just pretend like you knew what I was saying when you actually didn't. So when you wrote down the ratio that had the smallest numbers possible, what did you get for that, please? Anissa? So 3, 6, 3. Is there a number that will go into 3 and 6? So really, all these are divisible by 6 then, aren't they? So what might that be then, Anissa? 1 and then 2 and then 1. So that's what's called the empirical formula, which is sort of like a reduced down molecular formula. Like, why does this matter? Who cares? Well, the thing about this is okay, have you seen crime shows and they'll find a white powder and they're trying to figure out what it is? So what they do is they do different types of analysis. So we can actually burn sugar, like it will actually catch on fire. Like, I'm sure you've burnt a marshmallow before. It's quite, the calories inside are literally units of heat, which I find to be amazing, but I won't get off on a tangent about random chemistry stuff. Yeah, so when you burn a calorie, you legit burn a calorie. So the way they find the calories is they set stuff on fire in a lab in what's called a calorimeter, and then they figure out how much it heats up water.
So they
anyway,
burn McDonald's cheeseburgers.
Yes, they do. People do that for a living. All right. Now, wait. What I was saying was, what happens is a computer or whatever, when you burn this, they can figure out the lowest ratio of the stuff inside. They can get percentages of the different elements inside. So a computer will give you this, okay? And then what has to happen is the scientists, whatever pieces of information they do have, perhaps they know the mass of a mole of it or something like that, they can go back and figure out the molecular compound. But they basically, this reduced down thing is what they get when they do analyses. Yeah, there you go. So reduced picture of the real thing. Now, sometimes, like if I have carbon dioxide, right? What carbon dioxide looks like, we have this one's, it doesn't matter, you don't know the difference, but carbon's supposed to be black. So I have 1 carbon and 2 oxygens. So this is an O and a C and an O. This is what carbon dioxide looks like. That's its molecular formula. Does it have a different empirical formula? No. So sometimes they're the same if it's already in the lowest ratio possible. But depending on the molecule, they aren't always the same. So what I'd like you to do on the paper that you picked up on the way in the door, I would like you to do 1 through 5. And you can just do that directly on that sheet. The answer's on the back. So to go from molecular, which is what you were given, to empirical, that's pretty cool. Like, you just act like you're in 3rd grade and divide them by the greatest common factor.
Yep.
Yes! I have a degree to teach middle school math, and I remember the words sometimes. Don't tell my son, because he apparently doesn't think I can teach him stuff. That's fine. Not mad about it. So the thing is to go the other way, to get the empirical formula when you don't have anything, get in the molecular formula from the empirical formula. This involves some math and a poem. So remember I told you percent to mass, mass to mole divided by small, multiplied to whole, but you should have that kind of in your brain now. So here's the first example. So example 1, write this down. Determine if I put EF, well, you know that means empirical formula? Okay, whatever, I'm writing it down, never mind.
What would this be step?
This is not a step because this is the problem. Determine the empirical formula. Just saying.
That sounds like step.
Determine. Do you want to do this?
No.
Hush. Determine the empirical formula for a compound that contains 35.98% aluminum and 64.02% sulfur. Okay, so you got it? Now, the first step is percent to mass. This is the easiest step because what you're going to do, let's see. Oh, I'm going to go down too far. Okay, so the first step is you're going to take the percent and you're honest to God just going to change it to mass. So I'm going to go 35.98 grams of aluminum. Tough stuff, huh?
Yeah.
It's not hard, but here's the thing. If you can't remember the little poem, you're not going to know what to do. So that's going to be something you need to study. And the next step, I'm just going to kind of do it all together. But the next step, if you remember, open the door for Nyla, please, somebody. If you remember, the next step was percent to mass, mass to mole. If I was about to convert this to moles, wouldn't that be the first thing I was about to do? You okay? Right here. Hello? Awesome.
Yeah, she's hard.
Alright, the next thing is we're going to go 64.02 grams of sulfur. So that's percent to mass. That's the first step. And then step 2 is mass to mole. Can you convert both of these to moles in 2 different problems? Go ahead and do it. I'm going to rewrite this up here. That looks terrible. Okay, so you're converting both of these to moles right now. on this step right here that you're about to do, it's a good idea to go to 2 decimal places, but when you write down these moles, 3 decimal places is even better, and you'll understand why in about 5 seconds. So if you only got 2 decimal places, maybe you look back at your calculator, or yeah. What did I do? Oh yeah, okay, my bad. I think I rounded up and then I should have done that, but thank you. Did everybody get this? Anybody need any help? I see a couple people writing. I'll give you a second. What's the next line? Percent to mass, mass to mole.
Divide by small.
So, what's the smallest number, everybody? 1.33 or 1.99?
3.
If you were to crack open the chemistry book without this little poem, this is some craziness. So,
are there like different like rules on this?
well, like this isn't a thing. This little poem's not a thing. You know what I mean? So you would just need to know the steps without having a way
The
to
other teachers
navigate.
teach you that.
I don't know if they. We are talked about using the poem, so they should all be using it.
They got the magic tricks.
They don't have the magic tricks, but yeah. So I think they're all doing the poem. So if you talk to your friends, they'll all have the poem. Yeah, we all agreed on that. So this is going to give me 1 mole of aluminum, and this is going to give me. Now, okay, this step right here. I know I'm rounding it. I'm going to explain why. This step, this is our mole ratio. The mole ratio is what, like, basically I'm trying to write a formula, and I need these little numbers down here. These mole ratios are going to be my subscripts. So, when you get to this step, your answer should come out to be a whole number, 0.2, which is 1/5. 0.25, which is 1/4. 0.33, which is 1/3. 0.5, which is 1/2. 0.67, which is 2/3. 0.75, which is 3/4. That's really it. You should get something like that. It should either be a whole number or an easy to look at fraction. You know that 0.2 is 1/5, right?
Yep.
0.2, 0.25, 0.33, 0.5, and maybe some 0.67, but usually it's those first couple. So you're looking for a nice, so you see on my calculator your calculator too, when you divide this by this, you get 1.497. That's the 0.5 that I'm looking for. It should be within 100. You know what I mean by 100? 2 decimal places. Like you can round it the hundreds place. You can't round it like the ones place or anything. So, percent to mass. Mass to mole, divided by small. And then the last step is multiply by whole. Multiply till whole. So, sometimes these both will be whole numbers. That is not the case right now. What do I need to multiply both of these by to get a whole number? By 2. So times 2, times 2. So, watch, I want to make sure everybody sees what I'm doing so it don't look like a magic trick, okay? The purpose of doing this, we were solving for empirical formulas. We're trying to get a formula. So, 1 times 2 is going to give me 2 aluminums. See what I'm saying? And then right here, 1.5 times 2 is going to be 3, and that's the sulfur subscript. And I'm done.
Oh.
Yeah. Well, most of the time, listen to me, most of the time, okay, first of all, it's a molecular formula, so most of the time they're going to be covalent. So, and those don't balance because they don't have charges. But yeah, This is just an example to get you started. From here on out, they're probably going to be hydrocarbons or stuff with oxygen and hydrogen. They're not ionic, so no, you can't do that. But then also, if you were finding this and you read it through the computer, this would be what they would give you. Okay, so anyway, that's that. What I would like you guys to do now is on the paper that you picked up on the way in the door, I would like you to do 6A and 6A only. Yes. Because 1.5 times, okay, do you remember when we balanced combustion and we had 12.5 or 1.5 or 3.5? We had to multiply everything by 2? Because of that, can I put A, L, and then S 1.5? Can I do that?
No. It's just the smallest number they'll get it to.
Yeah, now listen to me. If I had gotten, let's pretend like I had gotten 1.33333 here. Guess what you would have to multiply everything by? 3, because that's a third, you understand? Alright, so if I had gotten 0.2, I'd have to multiply both of them by 5. That would give me a whole number. And you don't know how to do that, you can do it in a calculator till you get something. Did that answer your question?
Yeah.
Y'all good? Do 6A. So going back to the original example, well, we had C, this is on notes, so it goes back to your other paper. CH2O. What if we were given that is the empirical formula? Yeah, you kind of go backwards. Now, what they would do is say if the molar mass of the compound, let me do some quick math in my head, is 180, I believe it should be 180.12 grams per mole. What is the molecular formula? So here's the thing. If we think back, I'll wait for you. If we think back, excuse me, this, we already knew that this was the molecular formula. Normally you won't know. But what if we reduce all the subscripts by to get the empirical? We reduce them all by a factor of 6, right? We divided by 6. So, if we're trying to go the other way and get this, what we'll have to do is, it's the molecular formula mass divided by the empirical formula mass. So, your molecular formula mass will be given to you. It's 180.12 grams per mole. And then the empirical formula mass is 12.01 plus 1.01 plus 1.01. I think this actually ends up being, I didn't do it, oh gosh. Yeah, this actually ends up being, I think this is an 8. Yeah. So anyway, when I divide that, I get, what's the molar mass? 16 plus 2.02 plus 12.01. So, 12 plus 2 plus 16. I guess like 34. Maybe. I'm not feeling really good about my mental math right now. I need some more coffee. Usually pretty good at it.
Do you get a headache if you don't have coffee?
Yes, I'm totally dependent on it. I'm totally, so 30.03. When we divide these, do you see where I got this number? I did the molar mass of this. So when I divide those, I get 6. So what I have to do to get the molecular formula is I'm going to take the empirical formula, which is CH2O, and I'm going to multiply all the subscripts by 6, times 6, times 6, times 6. And that will give me C6H12O6. Do you understand why I multiplied all by 6? Because, listen, the molecular formula is 6 times heavier than the empirical formula. So that means I got to make it 6 times heavier by multiplying all the subscripts by 6.
So you just round with the 6.
Did I give you did I make this number up wrong?
Oh, no, actually no.
It's pretty close, right?
Yeah, that's great.
It's 5.998. Yeah. If you don't get it almost exactly a perfect whole number, then you did something wrong. But it should be very, very close. So 5.9998 is very close. Yes.
Did you do it with 180 with the 180?
Yeah.
180 minutes exactly.
Oh, I wrote down the wrong number. Okay, thank you. So it is 6. Cool. So that's how you do it. So now you can actually do 6B, and then you can also do the rest of the page. Yay!
More words.
Yeah. So the good news is,
You get to do a lot of work.
yeah, the good news is you have to do a lot of work, but the good news is that you get to do it in class. Because, do you want me to do another one?
Yeah, sure.
Do you really?
Wait,
I will.
if it's all one of the things that we do.
No, I'm not going to do another one. I'll do another example. Do you want me to do another example?
Yeah.
Okay, cool. So you're still on your notes paper, right? Oops. So on your notes paper, let's do a whole one. I wish So a compound contains, so example 2, I guess. That looks terrible. A compound contains 49.98 grams carbon and 19.47 grams hydrogen. Molar mass equals 58.12 grams per mole. Find EF and MF. So, molecular formula and empirical formula. I wrote it down quickly so you don't have to write so much. Are you allowed to wear that? I don't think you are. Can you really? Can you wear that? Are you allowed to wear that at school? Huh? So probably not in here either. So I'm going to go ahead and start working this out. You ready? So I'm going to go 49.98 grams of carbon. Percent to mass. They already gave you mass. Sometimes they'll give you mass. So you don't have to change the percent sign to grams. So percent to mass. I got to speed it up a little bit. And then mass to mole. So 19.47 grams of hydrogen. So that's the first step. Percent to mass, mass to mole. Go ahead and convert them by yourself to moles. You already know how to do that part. And like I said, do 3 decimal places here. Really. Okay, sorry about that. The numbers didn't come out right. 40.68 grams of carbon and 5.08 grams hydrogen and 54.24 grams oxygen. The molar mass, this is how you abbreviate molar mass, 2 capital M's. That's an AP chemistry thing, so I guess you're welcome. Is 118.1 grams per mole. So, find empirical formula and molecular formula. All better. If I get lost, the answer's right here. That's a joke. I hope you think it's funny. So, just kind of erase what you need to do. Yes, ma'am.
Is that 54.24?
Good question. I don't know. 54.24. Yeah. All better. Okay. So if I go ahead and kind of scroll just a little bit, take care of this craziness here. This one's good because it does have 3 elements, so I'm going to write these 3 things right on top of each other. 40.68. So percent of mass is already done. So 40.68 grams of carbon over 1. 5.08 grams of hydrogen over 1. And 54.24 grams of, I guess it was oxygen, probably, yeah. Now, can we convert all these to moles? So go ahead and do that. I promise I'm going to change the problem again. So 1 mole carbon, 12.01 grams. 1 mole of hydrogen, 1.01 grams. 1 mole of oxygen is 16.00 grams. Equals. Kind of got meshed together there. I'm going to draw a line. There. Alright, so here's my, these are my moles. What's the smallest one? It looks like a couple of y'all are still doing your mole calculations, yeah. I'll give you a second. So, as you got your moles, we divided by the smallest one. I'll let you work through that. I'm going to go grab a battery for my pen. It's starting to get a little wonky. Guys, did you get what I got? Hold on. 1 and then 1.5 and 1. A couple people start writing. I have to recalibrate this because I put a battery in. Okay. 1, 1.5 and 1. Did you get that? Yes. Alright, so percent of mass, mass of all, divided by small, multiply to whole. When I multiply to whole, what do I need to multiply them all by? 2. So times 2, that still looks bad, times 2. So my formula, it always goes CHO like cho. It's going to be 2 and then 3, and then 2. Notice that it's a lowest ratio possible. If you do the work and then you get 2, and then 4, and then 6 or something, then you know you messed up. Anyway, that's not all of it. I was given the molar mass. The molar mass that I was given was was 118.1. So, can I go from this page? C2H3O2. So I have C2H3O2. And then remember it's molecular formula mass, molar mass, divided by empirical formula mass. So 118 point, whatever I just said, 0.1 grams. And then I need to figure out the mass of this. So it's going to be 12.01, so 24.02 plus 3.03, so 25.03 plus 32. So what? 50. Or you use your calculator. Add them up. I don't know where my calculator. Oh, there it is. So what did you get for the molar mass of the C2H3O2? And what did you get? Did you add them up yet? Who added them up already? Anybody? Oh, everybody's pushing their buttons. Okay. So 59.05 maybe? Yeah. So I can easily look at that and see that I'm about to get 2, right? Because this is twice as heavy. And so now the molecular formula, so this is my empirical formula. This is a molecular formula. It's going to be C4H6O4. Is it good? That's a whole nother one. Now, as far as what your homework is, you have to finish out this page. I think it's number 9. You end up with a 0.2. Don't forget that that's times 5 to get it to whole. Finish out this whole page, answer them back. And then I'm about to come and check your homework because this is the first time I have a chance. You know, your homework page where there was 3 problems at the bottom you didn't do because it was like a chart at the top. Do those 3 problems on the percent composition page. Yeah. All right. Anyway, so I'm gonna come around and get your homework out for me. You have about 25 minutes or so to work. Not quite 25. Yeah, 25 minutes to work on this.
It was that. Yeah.
Where did my video go?